So guys, we start with the topic of friction and the concept of friction as a whole. So the first slide here, this is Engineering. You're welcome again to another wonderful video of physics channel. This is our introduction to friction and definition. So from earlier classes, we have studied that friction is defined as the force which acts, or let's keep down a note, the forces which act to oppose motion. So any force that acts on the body and has a tendency to oppose motion is called frictional force. So it is majorly written numerically, or let's say in physics as a FR. So it is called friction. So force that tends or opposes what motion is called what frictional force. A very quick example to explain that is just this case of when we have a rough surface. Please, one of the first conditions for friction to hold is what rough surface. Now, from what we have studied, then when the body is placed, this is the body of mass m as usual, is placed on a rough surface. From what we have studied, we know that what forces always act in pair, according to Sir Isaac Newton's third law of motion. So going by that third law of motion, we can say here that if a force is what acting along this direction to actually pull this particular body of mass m, frictional force will also act, which I will derive by FR in the other part. Now, this frictional force acting on the body will oppose the motion of the body, and the body will remain at a state of static equilibrium or rest, which we call it in our earlier classes. So now, in a nutshell, forces which act to oppose the direction of motion of an object is called frictional force. And that particular force is due to some fact. One of the first facts we can talk about frictional force that causes frictional force is what we call degree of roughness. Degree of roughness of the surface. So now what I'm trying to say here is that if we come into look of this particular body under microscope, we are going to see that because of the roughness of the nature of the ground, as we can see, because of the roughness of the nature of this ground, we can conclude that there will be some kind of interlocks at this particular layer. Now, something exists in this form, what we call something like roughness of the surface, which I'm trying to bring out on a microscopic view. So due to this roughness of surface, we say there will be friction. And that is more reason why we say in physics that this is what I call interlocks. These interlocks bring about the roughness, so which makes this body to remain at rest. It will cling the body to the ground. So because of that, when you apply force to that body, that particular interlock, roughness force that is acting under the layer of the block and the ground will keep the body at rest. So which increases or causes friction. So these are part of the factors that enhance frictional force in physics. So by and large, what I'm trying to say is that when surface is rough, friction is going to be high. And in the other case, when you have a smooth surface, which is another important thing, because I want to make this video very short, because we need to face the important things we need to know. When the surface of a body is smooth, we can conclude that there is no friction, because the interlocks will be broken. So, and when interlock is broken, so we say friction is less. So another important thing we can write is that for smooth surfaces, there is no friction. There is no friction. So that is that about that, and we need to understand that. Now, this is just the introduction part of our friction, and what I have said so far in this lesson is friction is just the force that tends to act against motion, or it opposes motion or the direction of force. So it acts in opposite direction, as you can see. Force is applying to this direction. Frictional force tends to appear excuse me, in the other direction. So the force that tends to oppose motion is called friction, and it is due to a degree of roughness between the surface and the ground. And I said, for smooth surfaces, there is no friction. Now, we can also write a lot of things about friction if we want to continue writing. And other things we can also keep in mind is that there are factors that affect friction, which we can put towards on that understanding. Now, factors affecting friction now. So if we want to talk about that, affecting friction or frictional force, anyhow you want to write it, it's the same thing. One of the first things we have talked about for my explanation is degree of roughness, which is very, very important, degree of roughness. Another important fact you can also keep down is what? The normal reaction. The normal reaction. So these are the two major factors or factors that affect what? Frictional force of the body. Now, about the other one we just talked about, that is talking about the normal reaction. We have talked about that before under our topic about Newton's laws of motion. But for those that are just joining us on our video, you can just listen to it. It's not what is too difficult to understand. Now, about that, we have a ground as usual. On top of the ground, we have a block. So we have a block on the ground, and say something of this nature, just trying to bring out something not straightforward like that. Now we say because the ground is what? Rough, friction will exist. And because friction will exist on the ground, when force is applied, we know because contact force, when there is a contact force, there will be what? The weight of this block will act every time. The weight of the block will act downward. Weight of the block is always mg. Weight of the block is always mg. So notice this, the weight of the block is always mg. And we talk about normal reaction of the block. The normal reaction of the block, as we have studied, normal reactions are always at the point of contact. So note that normal reaction also acts upward, weight of the body acts downward. So we can say normal reaction will balance what? The weight of the body. Now be careful about this because most students do ask, there's a contact between the body and the ground. So when there's a contact between the body and the ground, there will be what? There will be a normal reaction, which is also a type of force we have discussed. Force that acts at the point of contact is called normal reaction. So normal reaction force exists. There are different normal reaction. One will exist here because there is contact here. Now the overall, the sum total of all the normal reaction here, we say we act in upward direction. So this is the analysis we give to that. So this normal reaction is also affecting frictional force because the normal reaction tends to balance the weight, which we have as N is equals to what? Mg. So always keep that at the back of your mind. Now, like I said, remember there is a force acting in this direction, hence there is a frictional force because the body is rough. So which acts in opposite direction, which I write as Fr. So now I have actually explained that weight, a block, we have a weight of the body is always acting downward. Then the normal reaction of the body acts in opposite direction, that is in the point of contact. Normal reaction acts here, you can see. So which we balance what? The weight of this body. So which is what bring about this formula of normal reaction is equals to, some people write normal reaction as R, because I'm writing my own as N does not change anything. So it's always going to balance the weight. Now, there's another thing which I think is also very, very important for us to discuss here now, is the what? The net forces of all the forces acting in the horizontal direction. From what I have explained now, if you are following, I said frictional force is acting. This is what I am saying, my dear student. For understanding's sake, sorry about my diagram not drawn to scale. Now, for understanding's sake, frictional force is acting along the horizontal. For you to see, the normal reaction from what I've explained is acting along the vertical. So the overall force that acts in between these two is called what? Net contact force. Now, there will be a force. We all know that. There is always going to be a force that acts in between the two. That's force that acting between the normal reaction, you can say now, the normal reaction and the frictional force, which is horizontal reaction force and the vertical force. So the net contact of all, or the cumulative effect of all the horizontal force is called what? The net contact force. Now, horizontal force is here, force of the body, frictional force. So all the cumulative now is now taken as something like your hypotenuse or whatever you call it in mathematics. When you want to solve a triangle, as you can see, is now called net contact force. Because understanding really matters. This is the net contact force of the body, which is called R. So now, sometimes when you see R is equals to mg, what we are saying is what? The net contact force is what? Is equals to what? And also balance the weight, because it's just the horizontal component. You can write that in a note, because I'm moving to the next slide now. The cumulative means the sum total. Cumulative of all horizontal force. For horizontal force acting on the body is called the net contact force. Which is very important for us to keep in mind. So now that is the introduction to this phase and what we need to learn here. Then about the next slide, we move. Yes, we are to talk about the types of force, types of friction and its classification. Now about that, when we talk about type of friction in physics, we classify friction into two categories. Now we give classification of friction in two categories. Now, there is a particular friction we call dry friction. Dry friction. And there is another category of friction we call wet friction. And for now, about what we are going to be limiting ourselves into in this video is the dry friction, because that is what is required of our work on our syllabus. The wet friction has been discussed under the topic of viscosity and friction that affect liquids and gases, which we have discussed. But for now, we only limit ourselves to dry friction, and we are talking about friction that acts on what? On solid bodies, on solids. So any friction that tends to have between solids is called what? Dry friction, or any type of motion that opposes what? The motion of what? Of a solid body is called what? Dry friction. So based on this classification, we now group what? Friction into three, which we call static friction, which I believe you have studied in early classes. The other one is limiting friction. And the last one is kinetic friction. So please keep that at the back of your mind. Excuse me. Friction here is spelled like that. And the kinetic friction. Now, understanding this and how do we get it very well is just for us to keep in mind from our knowledge of Isaac Newton's law of motions. If you always remember that particular law about static equilibrium, it's very easy to understand static friction. Many of your textbooks can write static or limiting friction has been the same, but there is just a little bit of what's difference, which you need to understand. Now, kinetic friction sometimes can be called dynamic frictions for understanding's sake, and whereby static, sometimes some people will call it limiting friction. But we need to understand it very well, like I said, and understanding it means we don't make mistake when we interpreting it. Now, remember, this is friction and it's a very, very simple topic. And because it's very, very simple, we need to understand the concept too. Because not knowing concepts, we are going to suffer when we have questions. Now, this is the word grant, as usual. That is always my grant. Then, because it is grant, we have a blog on the grant, just a quick one, guys, for us to understand the concept very well. I'm not going to waste time, I promise. So we have a blog that is placed. on this rough surface. Because the ground is the what? Because it is rough, we expect friction to occur. Then this is the force was applied here, and we know that what, because of the interlocks and the nature of what, degree of nature of the ground and the surface, friction will also exist in opposite direction, because friction tends to oppose motion. Now, because of that, we can conclude from what I have explained here to you that we say frictional force. Just listen, guys, because we need to just make a conclusion here. Frictional force is proportional to what, like I said, it is being affected by the normal reaction of the body in the what, in the previous slide. So, and I said normal reaction of the body is the same thing as what? Balance the weight of the body, which is mg. So directly we can say, numerically we say, or by formula wise, frictional force is proportional to normal reaction, which is mass times acceleration due to gravity. So from here we say frictional force is now equals to, there will be a constant of proportionality, which is the degree of roughness, which we write as mu mg. Now this mu is called coefficient of friction, either static or limiting friction. And that is where we are going. So students need to keep that in mind, that frictional force is given as mu mg, and this mu coefficient depends on the nature of roughness, of surface, nature of roughness of surface. Now, from this, there is this elementary knowledge you might have studied before. Now, friction depends on two things: normal reaction and what? The coefficient of friction, or what? The nature of the roughness of the surface. Friction do not depend. That's another important thing you can note, that which I believe you have studied before in your early classes. Friction do not depend on the what? On the area of the surface. No matter how big this thing is, I'm talking about this block, friction does not have any effect on the area. So area of surface, or surfaces, as the case may be, a surface might be more than one, will not affect friction, will not affect friction. So I hope students are getting this, because that is the most important thing, understanding why we are here. We are here for you to get all these things without having any issues. Now, so far friction is what? Is proportional to what? From the formula we have now, which is this, is equals to mu mg, whereby mu is called what? Coefficient of friction. Now, what we are saying now is that friction is proportional, frictional force is proportional to what? The normal reaction. It is normal reaction affect friction. The higher the normal reaction, the higher frictional force. Now, body will continue to remain at rest. Now, going back to what we learned from Isaac Newton's law of motion, body will continue to remain at rest in as much that the amount of force applied on this particular body of mass m is not sufficient to what? To break the interlocks that exist between the body and the ground, which cause friction. I hope students are getting this. Now, what I'm saying here in essence is that if I apply, let's say, the friction, for understanding sake, I'm not going to waste your time. Let's say the friction on this thing is 10 Newton. Let's start. That's the total number of force that is keeping the body at static equilibrium. So if this particular force is that is keeping that body at static equilibrium, if I apply, we start with our illustration. If I apply the first force, let me apply the force of 6 Newton. Let me ask you a simple question. What will happen to the body? Will the body move? The answer is what? No. Why? Because friction acting on the body is what? Is 10 Newton. That means the body will still remain at rest. Now we move. No, the amount of force that is applied to a body and keep the body at static equilibrium, or the type of force that is acting on a body of friction that keep the body at static equilibrium, is called static friction. So force that does not move the body, or that still would allow the friction of the body to exist, is called what? Static friction. The word static means equilibrium, which we have discussed under Newton's law of motion. Now, if I increase the force now to 9 Newton, what will happen, my dear student? It will still be at rest. The body will still be exhibiting static equilibrium. Now, maybe now, and I increase the body into what we call the third force applied to this body, 9.99 Newton. What do you think will happen, guys? Will the body move or still be at equilibrium? You know, the frictional force here is 10. This is 9.99. It's 9.99 up to 10. I'm just testing your mathematics skill. Now, if you go by this, you will see that the body will be on the verge of what? Will still be at equilibrium because it's not up to it. Now, look at this, guys. If I apply the fourth force, which is exactly 10 Newton or 10.0, which is 10 Newton, onto the body, what do you think will be the effect on the body? Will it move? It will not move. It will exactly, but the body has now changed from being static to a type of friction we call limit, because the body is now ready. Any slight touch or any slight force, any slight external agent that come to touch the body will now what? Move the body. Then the body will start moving. So when a force that is equal to the frictional force is applied on the body has changed from its position of being static and has now moved to what we call what? Limiting friction. So the limiting friction of the body, according to what I have explained here, is 10 Newton, because that is the maximum limit the body can open. That's maximum limit of force this particular body can put. So at that point, the body will not be at rest, but it has not started moving. I hope you get that. Body is not at rest, but it has not started moving. But it is at its what? Limiting friction. Now, but in the moment I now apply the fifth force, which we call let's say 10.2 Newton, for example, what you see now is what? The body will now start moving. And when body starts moving, we say such friction is now what? Kinetic or dynamic friction. So I hope students understand this. So in a nutshell, I can just make a conclusion that what? Now, when the body starts moving, we can keep a note just for us to move on. When the body starts moving, due to less interlocks, then we can say kinetic friction is less than limiting friction. Another important thing, you can say coefficient of limiting friction or kinetic friction is less than what? That of static friction. Please keep that in mind. It's very important. Then what am I saying here? Sorry about the marker. Okay, fine. Take this back. Now, what am I saying here now? I said kinetic friction is less than limiting friction. If kinetic friction is less than limiting friction, it means the limiting friction is greater than kinetic. So when body has started moving, what happened? The interlocks has been broken. And because the interlock has been broken, kinetic friction is less than limiting friction. I hope you understand that, right? Because what we are trying to say is that what the limiting friction has been exceeded. And when the limiting friction has been exceeded, that means the amount of force of limiting friction is very, very greater from what I've explained. You can see, look at the limiting friction now. You can see it's greater than what the kinetic friction. So the kinetic friction is just that small amount of force that is added to the limiting friction to let the body start moving. So these two facts is very, very important. You can be asked in objective or multiple choice question about the relation of kinetic and limiting friction. Kinetic friction is always less than limiting friction. So this is the way we classify force. In this chapter, we just talked about the types of friction and its classification and explained them with a simple example for understanding's sake. So we move to the next slide, which is the third. Oh, fine. Now we have angle of friction and angle of repose. Now about angle of friction, which is another important thing we need to study. Now, we need to be careful about this because there are a lot of things we just need to understand. Now, before we talk about angle of friction, my dear students, we will talk about the angle of reproach. Now, angle of reproach, let's start with that. Many times, students think angle of friction is something as angle of reproach. But let me just give you the difference or differences between them. Now, angle of reproach, which is also taken as theta, in this case, I will draw. I just have to draw. I have a ground. On top of the ground, I have a body. Now, from what we have just talked about, this is what a rough surface, because if it is not rough, friction will not occur, right? So if we say we have, I've explained what we call, let me change the color, the normal contact force, the net contact force acting on a body, I told you is called R, just for you to see. Then from this body, already discussed as well, we have a frictional force. Force reacts like this. You have frictional force react to oppose the motion. And because of that, normal contact force is the sum total or cumulative of all horizontal forces. So the angle between the normal contact force, this is the ground, which is the rough surface, my dear students. So angle between the normal contact force and the horizontal force. Now, the horizontal force, the vertical force here is the normal reaction. We've talked about that, which always balance weight. Then here you have what? You have the frictional force on the horizontal force. So from here, we say angle that acts between you can say angle that acts between the normal reaction and the horizontal force is called angle of repose. From here, let's use our trigonometric understanding. From here, this is you can see horizontal force is our what? You can see is our what? Reaction. So we can say opposite, and the vertical force is our what? Normal reaction. So from here, opposite over adjacent. This is normal reaction force. For understanding's sake, it is very important to understand and not to cram. This understanding is very, very important. So normal reaction is the vertical force, whereby the horizontal force, the sum total of horizontal force, I said is what? Is the net contact force. So now from there we say, directly we say opposite over adjacent from trig is tan theta is equals to opposite is the net contact force R over vertical force is M. I hope I'm communicating. So if we go by that, you can see it's very, very simple to understand, because we need to understand all these concepts, because if we don't get them, it will cause what? It will wreak havoc. Remember, we say frictional force from the formula we derived the other time is equals to mu N, and N is equals to what? Mg. So this normal reaction is our what? Horizontal frictional force. So going directly from that, we have tan theta is equals to, frictional force, which is the net contact force acting here, which is equals to mu N. I just substitute, divided by N. What happened? N gets cancelled out. So we say tan theta is equals to mu. So now this direct formula here is also very, very important for dear students to keep at the back of their mind. This formula directly as mu is equals to tan theta, whereby mu is the coefficient of what? Static or limiting friction, which we have studied and we say depends on the nature of roughness. So my point now is that the angle here that acts between the net contact force and the normal reaction is called angle of what? Angle of repose. And from angle of repose, we can say the coefficient of friction is equals to tan of the angle of what? Of angle of repose. So we need to understand that. So very important for you to keep this formula in mind, because we are going to be using it directly to solve what? A lot of what? Numericals and calculation. So we can say angle between the horizontal force, the horizontal frictional force, and normal reaction. Place RxN here means normal reaction. So keep that on the back of your mind, and that is the first one. Then the second one is talking about another important one we can keep at the back of our mind, which we call the angle of Reproach. So it's not writing. So angle of Reproach, angle of friction, rather. However, angle of friction, in the case of angle of friction, we are going to use the diagram that is provided in this slide to explain how we come about angle of friction, which is one of the most important things you have to know. When a body is what is inclined at an angle of theta to the horizontal, as we have studied, now a block is placed, you can see on top of it as been shown here. So what we want to prove here is that the angle here that is placed to the horizontal is called the angle of friction. That is the angle between which we are going to talk very well now when I derive, because derivation is somehow important for us to understand concept very well. From here, we have studied before from Sir Isaac Newton law of motion that here the block is placed, the mass of the block is, and please listen so that you can get this. Now here it is very, very simple. We know there is a contact between the block and the surface there. So normal reaction we act, which we've talked about. Angled water, the force that acts at every point of contact is called normal reaction. Now here, please, I want to resolve this into simple components. I'm not doing something that is kind of difficult. So look at this now. I'm just trying to bring out a line, understanding sake. Please watch, and that shows interlocks or whatever. Then we talk about normal reaction is going to act at this surface. The normal reaction acting upward, normal reaction N. The weight of the block is acting downward. I'm just trying to resolve this into components from our free body diagram we have studied. So normal reaction is acting upward from what I told you, and the weight of a body, every system of body, the weight is always acting downward. So normal reaction will balance the weight. Yes, fine. Then look at this angle theta. The body is kept at an angle of theta to the horizontal. So now we say we resolve that angle to, so because of that, we try to balance out something, we bring this so that we can have something like a corresponding angle, which you've learned, this theta here will be equals to what? The theta here. That is a kind of corresponding angle are equal. I hope students are following. Because of that, now we can now use our SOCATRA knowledge now to bring out what? I have resolved this into two components. Now, if I balance that, let's change the color for understanding. So please, I hope students are following because this is very important. We are going to have something like a triangle like this in this form. Watch. And see, trying to balance out that. So if I have a triangle, this is the hypotenuse now, which is quite simple. This is the, you can see, the direction of the force. Now, from this body initially, from what we have explained, we know that the force, you can see, frictional force, reacts, sorry, this is writing back. This is frictional force react like this, whereby the force applied to the body reacts in opposite direction. Then I try to balance the normal reaction and the weight as well as the angle. So now resolving the force acting here, from here, this is opposite, see, horizontal force is opposite over hypotenuse, whereby the vertical force is what? Adjacent, you can see, over hypotenuse. So from SOCATRA, we know adjacent over hypotenuse is cosine, whereby opposite over hypotenuse is what? Sine. So what we are saying now is that the force that reacts downward here, because this is opposite, you can see this is opposite. Opposite, here is opposite. And the other one that reacts vertically is what? Adjacent. So now we can just write to keep it in mind. So for every time you have questions, because we are going to have questions, not that we like to teach something that is difficult or it's for us to understand that questions will definitely come. So when a question comes, you don't need to panic when you get it. So horizontal force, there are two forces now, horizontal force and vertical. This is the vertical force. Now, with respect to the weight, you know, weight is equal to mg, you know that. Weight is mg. So if I say horizontal force now, I'll just write it in a component. Horizontal force Where do we have horizontal force from what we did here? Horizontal force is always what? The frictional force, the direction of friction. You can say opposite, that is horizontal. Opposite, opposite, that is our mg. See, somebody was mg sine theta. Then vertical force. These are always the way we resolve. Vertical force, which is the one that is acting in the direction of the weight, is mg cos theta. So where is the direction of horizontal force? That is the frictional force. So we can now say, therefore, the horizontal force, which is the frictional force, is equals to what? Mg sine theta. And the vertical force, which is the weight or the normal reaction from what I did here. Normal reaction is vertical force. Horizontal force is what? The normal contact force, which is frictional force. And the normal reaction force is what? Mg cos theta. And remember, from what we have also studied, that frictional force formula is equals to mu n. So what is frictional force now? Frictional force is what? Mg sine theta is equals to mu. What is normal reaction? Mg cos theta. Mg cos theta. What happened? Mg gets cancelled out. What you have, make use of a formula, you have mu is now equals to sine theta over what? Cos theta, which is equals to what? Tan theta. So now you can see, if you watch very carefully, the same formula we have gotten for the first one is also the same thing we got for the second one. That is, the coefficient of friction is always equals to what? Tan theta. But we need to understand two things. When a body is what? Is tied up a ceiling like this, or is on the verge of sliding. This body is about to slide. The frictional force acting on the body is mg sine theta. You have two formulas. And the normal reaction acting on the body is mg cos theta. So two important things when the body is what? Is about what? Is on the verge of sliding. So we can just keep a note just to finish this. Just a simple note, nota bene, that this block here, the block will start sliding. We start sliding when the angle of friction, which is theta, is equals to theta half. So please keep that in mind. And what do I mean by that? This angle of friction here, the angle here is called angle of friction. That is when the body is on the verge of sliding, the angle between the body, as the body is about to slide, is called angle of friction. Now, the body will start sliding as when the angle of friction is equals to what? The total angle of what? There is what? Of the net contact force. And at that point, we say it is equals to what? Tan theta. When they are equal, you can say when frictional force is equals to mu n, body will start sliding. As the points from my explanation, when I do classification of friction, when you have block and you apply force, the body will start moving as at the point at which frictional force is approaching the value of mu n. So when frictional force is approaching mu n, body will start sliding, or body will start sliding. So when the angle of friction is equals to what? The total contact force of the body, the angle of the total contact, that is when this angle here is equals to the angle at which the body or the total body here has been resolved, the body will now start to slide. And at that point, you know that frictional force is mg sine theta, normal reaction is what? Mg cos theta. So that is all about that. I think the next phase should be the last phase, which is the one for the advanced level students, which is the cases of sliding. Now, a very, very cool one here. That is the cases of block over block, which is the last phase for these friction cases. Now, this is more or less like what we have discussed, but we need to discuss this well, because it's just like a simple concept. It's a simple concept, though, but it requires understanding. Now, when we talk about sliding of blocks over blocks, maybe we should keep a note before we write. I think that would be better. And for us to do that, let's write, let's say, on a rough surface. I think it's important. Let's just write the note, just for understanding's sake. On a rough surface, on a rough surface, a body at rest, a body at rest, a body at rest, we slide. We slide only if some external force, on the body approaches mu n. So what I'm trying to say here is just, like I said, it's just a simple concept that you all can understand. For understanding's sake, look at this, guys. Sorry, guys. Now we have a body. Most of the time we say body, a gland. And because there is a gland, we've talked about this time and time again. It's just for every time I just like to explain things. This is a block of mass, capital M. It's being dragged by a force, F, as you can see. Now this body will start moving. When the body will start undergoing, kinetic friction when the value of the force acting on the body is approaching the frictional force formula, which is mu n. So the concept I want to teach under the cases of block over block, most of the critical questions you think are difficult is just to understand that body will move over another body. As in the case of these blocks, according to this, when the value of the force acting on the body is equals to the frictional force, or is approaching the value of frictional force, that is when the body will start moving. Friction will act in the other part. So now, when we now want to look at a case study of that, we consider a situation of this kind of diagram you can see in front of you. This one's here. So if you look at it now, you are going to see that here you have a case of block over block, which is a very good illustration from the slide. So what we are going to have here is that we are going to have two cases. I think maybe I should just draw or leave it for you guys to let me draw. Diagram not done to scale. It's just wasting my time. I just don't want to use my hand to draw. We have cases of what you can see here. I just want to show you in the way you are going to see it in the exam. Please listen and just use your last energy to understand it, because it's also important. Now if this ground is smooth, what does that mean? From the beginning of the concept, I said when a ground is smooth, what happens? Friction will not exist, right? Fine, good, you are following. Now here, let's say this one is having mass of capital letter M, just an illustration. And this one is having a mass of small letter m. Taken? Now, what we want to consider in this minute experiment is at what point will this block, this small letter m block, move or slide over the other block, which is capital letter M. So, and I said that will only happen if the value of the force applied to the body is equal to is approaching mu n. That is the only concept. Now, because here, guys, no friction, body is smooth, right? Because there is no friction here. Here, there is no friction. But here, there is friction. Is there no friction? There should be friction because the body is also having contact with each other. As you can see, these two blocks. Now, there will be a friction because there will be a degree of roughness at this particular point. Are you getting it? Illustrations are very important. in understanding physics. Now, even not only physics, in understanding anything in life. So back to what I'm saying now. Here, now there'll be a coefficient of friction that exists between these two blocks, which we call mu. Coefficient of friction there exists because of the what? Nature of roughness. So now we say if this body is moving with a force of F, now these two bodies are going to move together. Why are they moving together? When a force is applied, because they are on top of each other. If I apply a force to this block, you can see in front of you. What happens? The bodies start what? Moving together. That means the two bodies are going to have what we call common acceleration. This is just interpretation. Now, because of that, we can recall from Newton's second law of motion that F is equals to ma, right? F equals to ma. So if they are having common acceleration, my dear student, so the acceleration of the two bodies, acceleration is a vector quantity, will be equals to the force acting that was applied to the body over what is the mass of the two bodies? The mass of these two bodies is what? Capital M plus what? Plus small m. In case of illustration, this one can be 30, this one can be 20. That means if you want to get the total mass, you add them together. Do you understand? So we say if acceleration is now force over what? Mass. The mass acting on the two bodies is what? Capital M plus small m. So that is the common acceleration of these bodies. Now, having said that, now we now say this particular small mass, we can write another important note. Small m will slide. I just want to keep the note, we slide over capital M. Are you there? When the force acting on this approaches, force is equals to ma, which we've talked. When the force acting on this body approaches what? Mu n, which is the concept I've talked about. This is the major concept on the case of block over block. Body will slide over another body when the force acting on the body is very, very close or is closer to what? The value of the frictional force, because friction tends to exist at this point. So my point here is that, my dear student, so what is the force on this body? The force on the body from Newton is ma. So what is ma? M is small letter m. What is the common acceleration? The body is moving together with common acceleration of F capital letter M plus small m is equals to mu. What is the formula for normal reaction? Normal reaction is always equals to what? Mg, which you all guys know. I hope you still remember that. So mu mg. What happened, my dear students? M gets cancelled out. And here we can bring about the force acting on this body will now be equals, if you make this F sub your formula, I'm not going to waste your time here. You say F is equals to, you cross multiply. That is mu, open bracket, capital M plus small m into bracket G. So this is the formula you need to keep in mind, that body will start sliding over another body in case of two body when the force acting on the body is approaching the value of mu n. So that's the concept we teach under this. And the formula we use directly is the force that must act on top of the small body must be equals to the coefficient of friction, open the bracket, big mass plus small mass, then multiply by G. What is G? Acceleration, which is 10 meters, approximately 10 meters per second. So guys, this is all about this. So the next thing will be illustration and examples, which is the most important thing, because I haven't learned concept without doing practice. You will not be sure about your level of understanding in the concept. So be that as it may, my dear students. So let's quickly do the last part of it, which is the illustration part. I hope the illustration questions are not too much as prepared by the student. So let's see that. Oh, wow. I think this is much, but all the same, I will just give you hints on how to do them, then you leave answers in the comment section. So let's start with the first one, guys. The first question is a block of mass 12 kg rests on a horizontal floor. Good. is resting on horizontal floor. Then we have the coefficient of friction is 0.35. Is a dimensionless quantity, it has no SI unit. Determine the minimum force required to move the block when pulling at an angle of 30 degrees to the horizontal. Now that we have learned concept, we can apply formula directly. Remember, we said the force acting on a body, frictional force, is equals to mu mg or mu n. Let me write it one by one. Mu n. And n is equals to what? Remember, when it is being acted upon by a body to the horizontal, normal reaction is mg cos theta, right? Remember that? We talked about that. You can see the time the minimum force required to move the block when pulling the angle of 30 degrees to the horizontal. So we said normal reaction is mg cos theta, and frictional force is mg sin theta. Remember, this is very important. So directly, I can just write this and solve that. F is equals to, you can see mu. What is normal reaction? Mg cos theta. So now it's easy to use formula to solve questions when you understand the concept that holds for it. So directly, I will just substitute the parameters. Here, what is the mass? Mass is 12 kg. What is the coefficient of friction? Mu, 0.35. What is theta? Theta is 30. So directly, by direct substitution, we can say force is now equals to 0.35 multiplied by the mass. The mass of the body is 12. G is always 10. I hope you know that. And cos of 30 degrees. So the rest, I leave it for you to punch your calculator because of time, and you say the answer. That is the answer to that. And I hope students understand that. Question 1. Then question 2. Question 2 solution will be done to this side. And for question 2, let me manage it for it. I'm rushing because of time. I'm kind of overused my time. We have a mass, a 5 kg mass on the horizontal platform, accelerated at the rate of 0.2 meters per second squared. When a horizontal force of 10 Newton applied to it, calculate the coefficient of friction, between the platform, between it and the platform. Now, this is a very simple question because you know friction exists. We know that F is equals to mp, second law of motion. We've talked about that. And frictional force is also equals to mu n. So where n is mg, anytime, any day. Now, without wasting time, mass was given to be 5. See, it is accelerated at this. Then you can get the force acting on the body because you know the acceleration. And if you get the force, then the horizontal force, when the horizontal force of 10 Newton is calculate the coefficient of friction. You know, what I'm trying to say, guys, is when you know concept, questions become very easy. Now, horizontal force is frictional force, which you know, it is 10 Newton. But there is a force also acting on the body, which was trying to pull the body. Now, first thing I will do here is to get the amount of force. Acceleration is given in question. I hope my students are following. Acceleration is 0.2 meters per second squared. The mass of the body is 5. You can draw if you wish to draw, but because I've explained concept, I'm trying to make it very fast. Let's see the force that was applied to the body. You know, there will be friction. There are two forces on the horizontal, friction and the normal force. The body will move only if and if only the force applied to the body is greater than the what? Frictional force already discussed. So directly from F equals to ma, you can get the force. Just multiply, you can see the mass is 5. The acceleration is 0.2. I hope students get that. 5 times 0.2 should be 1, if I'm not mistaken. That's 5 times 2 over 10. And that is 1 Newton, or 1.0 Newton. So if we have 1.0 Newton as the amount of force acting on the body, are you there? And the horizontal force of the body is 10 Newton. That means the frictional force acting on this body is 10 Newton. So now, directly, another person can just say, okay, I want to use this same formula. I will just say, okay, fine. It's simple for me to know that if I make coefficient of friction subject of formula, it will be equals to the force over the normal reaction. The force acting on this one is ma. Then the normal reaction acting on this one is mg. So another person will just say, is just saying the acceleration over the what? Over the gravity. You know, understanding concept is very good. So which is 0.2 over gravity is, I think it should be 10. The person that typed this thing omits 10. So 0.2 divided by 10. Then you say it should be your answer. Then it's also the same thing here, but the approach I want to give to this question here is quite different. A 5 kg mass on the horizontal plate was accelerated at the rate of this. When the horizontal force of 10 Newton is applied, this was the force that was applied. You can see force applied is 10 Newton. Is applied to it. A 5 kg mass on the rubber is accelerated. The body accelerates when this force was applied to it. So a force of 10 Newton was applied to the body. And because the force of 10 Newton was applied to the body horizontally, the body starts what? Moving. So I think it's a direct question. I was thinking before that it was two forces that is acting on the body, that is frictional force. It was when the force of 10 Newton was applied to the body starts what? Moving. So the question now asks for you to find the coefficient of friction of the body. So it's a direct question. Coefficient of friction is what? The force acting on the body divided by the what? Divided by the normal reaction, which is what? Mg. So here in this case is a direct question. So it's good to understand concept. So please, I just need to make sure you get it. It's not about mis-solving. Mis-solving is very easy. So the force acting on this body is 10 Newton. Then the normal reaction is what? Mg. What's the mass? 5. What is the acceleration due to gravity is 10. So this is what I want to do. This is 10 over 50. What's 10 over 50? That's 1 over 5. That's 0.4, if I'm not mistaken. 1 over 5 should be 0.25. This 10 over 50 should be 0.25, if I'm not mistaken, or 0.2. 0.2. So 0.2 is correct. So my approach before, when I'm doing this is that I want to see the differences in the force that is acting on the body. Because what force of 10 Newton was applied to a body, whatever, I don't need anything of acceleration. So it's a simple question, just that it requires me to explain in details. Look at the third question here. The acceleration of the system above is dash. Now, to do this, we have to draw free body diagram as usual. So the simple way we can do that, we've done something like this under second law of motion. But here, the body was actually, you can see the body here was inclined at an angle of 30 degrees to the horizontal. And because it's inclined at an angle of 30 degrees, we know very well, as a matter of fact, that something will exist. This is the pulley. So tension will exist here, what we have studied. The tension will exist here. The weight of this thing is acting downward. So, but in this case, something will happen. Here, tension, but there's also what? Friction. Frictional force tends to occur to oppose the tension that is what? Dragging the force here. So we set some kind of relationship or formula, which we've done before. Here I can say the tension minus the frictional force is equals to MA, as F equals to F is equals to MA. The force at this point is tension here minus the frictional force here. But the one acting downward, weight is greater than tension. We say the weight minus the tension here is equals to MA. Now, guys, what have I done? F equals to MA is the formula I've used. I only resolve this in case of my free body diagram. So what you do now is that tension minus what is frictional force? Mg sine theta. You can see Mg sine theta is equals to MA. Let's substitute. You don't know tension minus, we know the mass, 20. See, 20 times 10. I will leave it for you to finish, times sine theta. What's the angle? Sine 30, the angle of friction, is equals to, what is M? 20A. So doing this, you have T, this is 200, that's 100, minus 100 is equals to, you can confirm all this, 20A. That's my first equation. I'll do the same thing for this one acting downward. What's the weight? Weight is mg, right? Weight is m is 30, g is 10. 30 times 10 is 300, minus tension is t, you don't know. The mass is 30. This is equation 2. You can solve equation 1 and 2 simultaneously, 300 minus T is equals to 30A. So if we solve this equation by adding them together, which is the fastest way to solve that, so this and this get cancelled out. Minus 100 plus 300 will give me 200 equals to 50A. So the acceleration of this system will be 200 divided by 50, and that will be equals to 4 meters per second. So I hope students understand that. I am sorry I'm rushing. It is because of time, like I said, but this is a very simple one from your free body diagram knowledge. You can understand the way I come about. So I hope you understand this. And in continuation to that, I think we have something. Two bodies, B, P and Q, 10 kg and 15 kg are connected by a light inextensible string as shown in the diagram. Fine. P is placed on the top, on the rough, this is not tough, on the rough surface. That means there's going to be friction. And the coefficient of friction is 0.5. If the acceleration of gravity G is 10 meters per second squared, calculate the magnitude of 1, normal reaction on P, 2, frictional force between P and the surface, 3, tension of the string, 4, forces which causes P and Q to accelerate, and 5, common acceleration of P and Q. You can see that I have a lot to do and I'm rushing. So now that means I just have to put you guys through. It's very simple. Now, because we have this is 10, just like what I saw now. This is 10 Newton, 10 kg, and this is 15 kg. So let me just resolve it. Choose something, tension we add. Let me use red like this. Then frictional force we add in the opposite direction, which was even shown. This is very good. So from what we said the other time, you know that it will be tension minus T. It's just like some of you that you like cram your memorizing. It's just like on that surface, it will be what? Tension minus what? Frictional force is equals to what? Is equals to MA. So what is frictional force? In this case, frictional force is equal because there is no angle. So frictional force formula, what is frictional force formula? Mu N, right? F equals to what? Mu N. So now we say T minus frictional force here is mu N. There is no angle. In this case, I use frictional force formula to be md sine theta because it was what? We have an angle of friction. Now I'm using mu N here because of what, guys? Because there is no angle. This was not inclined at any angle. Excuse me. Equals to MA. What's the mass? 10. A. So you can substitute tension minus mu. What is mu? It was given coefficient of friction is 0.5 times N. What is N? N is mg. So mu mg. N is mg. The full formula is FR is equals to mu mg. You just have to do all these things the way it should be done. I just want you to get them because it is important. But answering the question directly, if you want to take the question one by one, the first question is a normal reaction. What is normal reaction? N is equals to what? Mg. Normal reaction acting on the body is mg. You know that. Please note that. So it's very easy to calculate normal reaction on P. On P, you can see P and Q. P and Q. P is 10. This is PO. P is 10. So mass of P is 10 times what? Acceleration to the gravity is also 10. Excuse me. So you have 10 times 10 is what? 100 Newton. That's the normal reaction. You can see it's more or less like a simple Waec question. That's the first one. The second question says frictional force between P and the surface. What's frictional force? FR is equals to what? Mu N. What's N? Mg. Frictional force equals to mu. What's mu? 0.5. You can see times what is N? We just calculate N at P, 100. That is 50 Newton. That's the second answer. You can see they are short questions. I just like explaining things, but to solve them are very easy when you understand the explanation. The third one says, that's the third one, tension in the string. The tension in the string is now what will make you set this type of equation. What is mu N now? I've done that now. Mu N was what? 50. So I can just put 50 here instead of wasting my time. So we have 50 is equals to 10A. As the force at this point. What about the one acting downward? What's the equation? W minus T equals to MA. So I will also do that. I'm managing space. I hope this is the last question. And if it is not the last question, that means I still have to do them because we have to finish. Now, the second one, the one acting downward, I told you is always like that. Upward is T minus FR, downward is W minus T. If you are good in cramming, well, no problem, but I don't fancy that. So that is W minus T is equals to MA. So if we do that, you can see weight W is mg. What is the mass here? 15. What is the 10? 15 times 10, 150 minus T is equals to mass is 15. That is 15A. So that's the second equation, just like what we did now. 15, 150 minus T is equals to 15A. You can see from these two equations, you can solve for both tension and what? Acceleration. Now look at this. The third question is tension in the string. Force which causes P and Q to accelerate. And the fifth question is common acceleration between P and Q. Now, common acceleration between P and Q. See, is the acceleration you are going to get from this simultaneous equation. Tension in the string is the tension you are going to get from this formula. And if you remember the concept under actual machine and Isaac law of motion, I gave you a direct shortcut formula. If I want to get the acceleration from here, what I did something the other time, I added the two equations together. If we add these two equations together like that, what happens? This gets cancelled out. Then we have minus 50 plus 50. What do I have, guys? That's 100. Minus 50 plus 50 is 100. Then this is nothing but, we should move down there. 15 plus 10 is 25A. What happened? A is also equals to, more or less like what I did now, 100 over 25. Common acceleration is 4 meters per second squared. That's the acceleration. But the question asks for tension first. What do? Use any equation, simultaneous equation. So use any equation, you have tension minus 50. I'm using this equation, is equals to 10A. Now that my A is 4, tension minus 50 is equals to 10 times 4, 40. So I have tension in the string will be 40 plus 50, and that is 90 Newton. You can see the tension here is 90. The acceleration is what? 4 meters per second squared. So I've answered this, but there's one more question that I have not answered. Force which causes P and Q to accelerate. Force. What is the value of formula for force? Force that causes body to accelerate. That is the common force acting on the body. So the force that causes the body to accelerate, I told you, body will start moving as soon as the value of the force approaches what? Mu n. You can see everything is just repeating itself. So if you say F equals to ma, common force that will cause the body to accelerate is more or less as the total what? The total force acting on the what? On the body. So which is just F equals to mu, open bracket, capital M plus small m multiplied by G. Should I take that again? For those that want to know, the force that will cause the body to accelerate is just force is equals to, you said, is equals to, you have mu to bracket capital M plus small m. It was derived in the other stuff, G. So, and that is the only technical question here, which most of you might not be able to get. So mu, you already know mu, 0.5 is called coefficient of friction. You add the two, 10 plus 15 together, that's 25, you multiply by T. That will be the answer to forces that will cause the two bodies to accelerate. So I hope students understand this. This is all about friction. You can always watch the video. Don't forget to subscribe to the channel. And for cases of other illustrations and comprehensive details, you can join our online class for our online crash course. The next video will talk about rigid body, cases of momentum, and system of particles. So see you guys soon in my future video. Thanks and do have a wonderful time. Bye for now.